your request this evening of finding the area and the perimeter of each of these figures. I've seen you're working out, although I don't quite recall your answers, but I've seen your answers and I'm going to take an attempt on solving the problems also. Now, the first thing that we need to find is the perimeter. So we'll find the perimeter of this one. Perimeter, the measurement all the way around. And peri means around. So we will find the measurement all the way around. Now we are going to look to see if there is any missing side, and we will also include the missing side. So we will find the missing side and also include that in the perimeter. The first one that we have right here, this length is missing. This one is missing. Now, this is 10 centimeters. We have 1 centimeter here, 1 centimeter here. Therefore, if we take these 2 centimeters from the 10, what we will have here is 8 centimeters. So we will proceed in finding the perimeter. We're going to begin right here. So we'll mark that spot. And we are going to go all the way around and we'll end up at this spot again. So let's begin. We have 3 centimeters plus 1 plus 1, then plus 8. Up again, so we have plus 1, plus 1, plus 3, plus 10. So we are going to recheck to see if that is correct. We have 3, 1, 1, 8, 1, 1, 3. So it is 3, 1, 1, 8, 1, 1, 3, and then we have 10. 10. So we'll add all of those together, and the result is, I think we just put it right here. The result is, we're going to find an easy way to add that. So we have here, that's 10. 1 plus 1 plus 8, that's 10. We have another 10 here. And we have 5. So we have 10, 10. 20 plus 5, 25 plus 3, and that is 28 centimeters. So that's our perimeter. Perimeter is 28 centimeters. What about the area? For the area, we will divide this into 3 rectangles. These 2 rectangles turn out to be squares, but they are rectangles nonetheless. So area is equal to the area of this one, where we have 2 identical, 1 by 1, 1 by 1. So it is 2 times 1 times 1. So we have 1 by 1, these 2, and then we have what? Notice that if we take 1, as this entire thing is 3, if we take 1 from this, then this part will be 2. Let me say that again. We have, from here to here is 1 centimeter, all of this is 3 centimeters. So if we take 1 from this, then the rest will be 2. The remainder will be 2. So it is going to be 2 times 10. So that's plus 2 times 10. So this rectangle will be 2 by 10, and each one of these will be 1 by 1, which make them squares, but that does not prevent them from being rectangles. So the overall area is, this is going to be 1 times 1, which is this one is going to be 2 times 10. So that is going to be 20. So that is equal to 22 centimeters squared. So we may verify that what we have done so far. The perimeter, 3 plus 1 plus 1, we have that right here, 3 plus 1 plus 1 plus 8. Then we have plus 1 plus 1 plus 3. So 1 plus 1 plus 3. And then this one all the way here is 10. When we add those, we get 10 here, 10 there, and 15 there. So we'll end up with 28. And then the area will be the sum of these 3 rectangles, of which these 2 turn out to be squares, 1 by 1 squares. And then because we have taken 1 from here, this will be 2. So it is going to be 2 times 10, which is 20. And it's 2 of the small rectangles. So 2 plus 20, and that's 22 centimeters squared, or square centimeters. For this one, what do we make of it? We're going to take a look at the perimeter. Now, we have the perimeter. If we start at the same corner, we have this is known, this is known, this is known. This one is not known. This is known, and this is known. Also that one. So the only side that is missing in this one is this one. The only length that is missing is this. Now this is 15 centimeters. And we have 2 centimeters here. So 2 centimeters there and there. So we're going to take those 2 from the 15, and what we get will go right there. So notice that we have 2 centimeters here and 2 centimeters there. So in all, we have 4 centimeters. So we take that 4 centimeters from 15, and we will get 11 centimeters right there. Now we will proceed to find the perimeter. So we begin here. 4 plus 2 plus 2. So we have 4 plus 2 plus 2. There's only 11 plus 2 plus 2. Then we have another 4 here. And then finally we have 15. And we will put those together very quickly and see the result. 15. Now, this is 15 and this is 15. So we have 15 here and 15 there. So that's 30. That's 30. Then we have 6 plus 4. So that's 40 and 2. So that's 42 centimeters. Maybe we can take a second look at it. We're going to add those quickly. This turns out to be 15 along with this. So that's 30. So here we have 6. So we have 30 already. Here we have 6 plus 4 is 10. So that's 40. And then we have another 2 right there. So that's 42 centimeters. And that's our perimeter. Now we may go straight ahead and find the area. So that's your perimeter. So we're going to find your area. Notice again, that's a 2 by 2 rectangle. So that's a square also. So we have 2 rectangles here, which are 2 by 2. And then we have another rectangle here. However, the entire length here is 4 centimeters. So this is 4 centimeters. centimeters. So we have from here, the entire thing is 4 centimeters. From here to here is 2, therefore from here to here has to be 2. And by the way, the diagram is not drawn to scale. Therefore, the values might not look or might not appear to be proportionate inside of the figure. But we're going by the diagram that we have and the way that the calculations are correctly made. So we are making use of a diagram that is not drawn to scale. Therefore, the length will not look proportionate. For example, look at this. This is 4. Here is 2. But we can see with our naked eyes that this seems to be shorter than this, although both of them are 2 centimeters. And that is because the diagram is not drawn to scale. But it is 2 centimeters nonetheless. So we have another 2 centimeters here. So this will be, let's take this out, 2 centimeters right here. So this 2 centimeters should be multiplied by the 15 and we get 2 times 15. So that's 30. So we have here 8 plus 2 times 15 is 30. So we have 38 square centimeters, or so we say centimeters square. Right here we have another one, and no doubt we cannot just stick slave shape imagining that the diagram is drawn to scale. So it is not drawn to scale, but the calculations can be correctly made. And we're going to take a look at the perimeter again. Perimeter. And we're going to begin here. So if we begin here, 7, 5, 5. We don't know. 5, 5, 7, and 12. Now here, we have 5 plus 5. So these two lengths will be together 10 centimeters. And this is 12 centimeters. So we will have what? 12 minus 10. So that will be 2 centimeters right here. So we have 2 centimeters right here. So we have, for the perimeter, I know that the length of the sentence is going to be long. 7 plus 5 plus 5. So 7 plus 5 plus 5 plus 2 plus 5 plus 5 plus 2 plus 5 plus 5 plus 7. So we can say 7 plus 5 plus 5. Then we have 2 plus 5 plus 5 plus 7. Then finally 12. So 7 centimeters, 5 centimeters, 5 centimeters, 2 centimeters, 5 centimeters, 5 centimeters, 7 and 12. So your perimeter, let me make sure, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So what do we make of this? So we have 10 there and 10 there. Do we have any multiple of 12? Do we have any more multiples of 10? No. Can this be easily added? Let's see. Well, we just have to add the rest of them. So we have 10 here and 10 there. So that's we have 20. 20 plus 14. So that's 34. So we have 10 plus 10, 20 plus 14. I can write that down. So we have 10 plus 10 for these two. Then we have 12 plus 2, so that's 14 right there. And then we will have finally what's left? This plus 9. So our calculation will be shortened by saying 14 plus 9, that's 23, plus the other one. Now if the entire thing is 7 and 5 is right here, so this part is 5, so we have a 2 remaining there. So inside here, we can just put it right there. This will turn out to be 2 centimeters. And of course, the diagram is not drawn to scale, so it is not going to be proportionate. So we have 12 times 2, which turns out to be 24. And we have these two, which are identical squares, 5 by 5. So this will turn out to be 25 times 2, so that is 50 plus 24, which is 74 centimeters squared. Now, I'm going to take a second look at this, because this is 5 5s, 25, and this is 2 12s, 24. So we imagine that just by looking at it, it would be unthinkable that the area of this could be greater than the area of this one. But do not forget that this one is 2, and if it were to be drawn proportionately for 5 2, then you know this length will be what? 2.5 times this length. Because this is going to be 5 centimeters, and this will, sorry, this part is going to be 5 centimeters, and this will be 2 centimeters. So this length is 2.5 times this. And at the same time, this one is not as much as 2.5 times this. So let me see if we can explain it in a little bit more detail, because just by looking at the diagram, it might be unthinkable that this area could be larger than this. But what I'm saying is that it is not drawn to scale, for 1, and 2, that this dimension here is just 2 centimeters, should really be 2 centimeters, and then this one is 5. So let's take a look at it. So we have 5 times 5 as opposed to 2 times 12. That's what it is. And of course, no doubt, 5 times 5 is equal to 25, and this one is equal to 24. So it should not be unthinkable. It's just that it does not appear that way by looking at the diagram. And what I was saying is that we would check it mentally. 5 is 2.5 times 2. Yet still, this 12 is not as much as 2.5 times this 5. So while this 5 is 2.5 times this, this 12 is not as much as 2.5 times 5. Therefore, we can see that proportionately, this area should be larger, this one. The 5 by 5 should be larger than this, even though it does not appear so. So, I just said Mrs. Adams in Brooklyn, New York. Hope I didn't make any mistake, but I'm sure that if I did, then you will point it out to me, and I will take another go at it on another occasion. So, this is your request that I've granted to you, and I'm going to take a look at your answers and give you a card. Thank you for logging on to Richard James Mathematics Resources. Thank you for subscribing, and I'm sure that Richard James Mathematics Resources intended to have an international flavor. And my first international video, this is the first one, and it is done on the behalf of Mrs. Allen.